expression for energy of electron revolving around the nucleus. Now, when the electron is revolving around the nucleus, that time the total energy possessed by the electron is the sum of kinetic energy and potential energy. Now, kinetic energy and potential energy we need to find. Therefore, to find this kinetic energy, we will consider Bohr's first postulate. So, according to Bohr's first postulate, what is Bohr's first postulate? mv square upon r is equal to E square upon 4 pi epsilon 0 r square. Now this r will get cancelled and we multiply on both sides by half, and therefore we can say that this half mv square is equal to E square upon 8 pi epsilon 0 r. One of that already we have cancelled. Okay, now this is the expression for what? Kinetic energy. So we can say that kinetic energy is equal to E square upon 8 pi epsilon 0 r. This is expression for kinetic energy. Now let us derive expression for potential energy. All of us we know that this potential energy is equal to potential, that is electric potential into what? Charge. All of us we know that potential energy is what is charge into potential. So potential is what is V into charge of electron, what is minus E. Now what is the electric potential of the nucleus at a distance r? So that will be 1 upon 4 pi epsilon 0 into, it is E upon r, into this is what? Minus E. Okay, this is the potential due to the nucleus at a distance r, and here we have to consider only the hydrogen atom. So in hydrogen atom there is only one proton, that's why the potential created by the proton is what is 1 upon 4 pi epsilon 0 into E upon r, and thus we can say it is minus E square upon 4 pi epsilon 0 into r. This is formula for what? Potential energy. All of us have seen that this total energy is what? Sum of kinetic energy and potential energy, and therefore we can say that this total energy E is equal to kinetic energy, that is E square upon 8 pi epsilon 0 r minus, that means plus potential energy, that is minus E square upon 4 pi epsilon 0 r. Now what we can take outside, that is E square upon 4 pi epsilon 0 along with r. So here it will be 1 upon 2 minus 1. So 1 upon 2 minus 1, that will be what? Minus half, and therefore it will be what? Minus E square upon 8 pi epsilon 0 r. Okay, this is formula for what? Energy, total energy in terms of radius. In case if we don't know radius, then what we can say, just now only we have seen expression for radius. What is the expression for radius? What is the expression for radius? It is, we can say, it is epsilon 0 h square n square upon pi me square. Okay, so we can say that here, if we put the value of r into this equation, we can say that this E is equal to, it is minus E square upon 8 pi epsilon 0 into r. What is r? It is epsilon 0 h square n square upon pi me square. So here we can say that it is minus pi me, pi will get cancelled, so it is minus me raised to 4 upon 8 epsilon 0 square s square, and here we can say it is 1 upon n square. Here all these things, mass of the electron, charge of the electron, permittivity, Planck's constant, 8, all these are constants, and therefore we can say all these are constant, and thus the energy of the electron, it is inversely proportional to square of the principal quantum number. Okay, now here put these values, that is mass of electron, charge on electron, permittivity, E, all those if we put and if we calculate and if we convert that in terms of electron volt, then we can say that here the energy of the electron in the nth orbit is minus 13.6 upon n square, and this energy in terms of what? Electron volt. The negative sign shows that the electron is bound with the nucleus. Electron is bound with the nucleus, and this much positive potential we need to provide to the electron to ionize the electron, or we can say atom. Now this is energy in the nth orbit. So for the first orbit we can say n is equal to 1, and therefore energy associated in the first orbit is equal to what? Minus 13.6 electron volt. So for the second orbit n is equal to 2, so square of the 2 it will be 4, and this we can say that is minus 13.6 divided by 4, and that will be minus 3.4 something electron volt, just like that. And so on, we can find out the energy corresponding to all those orbits. Okay, so that's all, which is the expression for energy of the electron in the nth orbit. Okay.